All right, welcome to another second channel video. In this one, I'm just going to be talking about simulation nodes and things that I've learned how to do with them. So it's not going to be about any one thing. I'm just going to be rattling off things that I know. So let's start off by adding in a plane. It can be anything because we're not really going to be using the original geometry. So let's go over to geometry nodes. I'll hide this on the side for now. We'll pull it open if we need it. And we can add a new node tree. And just to explain what simulation nodes do, the simulation zone, we'll leave the original geometry for now, but we're going to delete it really soon. So let's bring in a simulation zone. It'll have these two nodes right here, and you can hook everything up like this. Basically, everything that happens in this zone right here is going to happen every single frame. So if we use a set position node right here, and we place it on the outside, it'll work just like you would expect it to. Even if you press play, it'll just stay right here. But if we put it in here, set it to something small like 0.01, and then we press play, this will move up this distance every single frame. And turns out you can kind of do a lot with that functionality. And just so this doesn't restart after, not very long, let's go back and just turn this to a really high number. I'm going to turn it to 30,000. It'll basically just not start over on its own. Okay, so now let's delete the original geometry, and I'm going to use some points for this to make it look kind of like a particle simulation. Let's add in a points node right here. You can drop this in. And a shortcut you'll see me use pretty often is a shift and left arrow. And that's basically just going to bring it back to the first frame to make the simulation restart like this. So I'm going to be using that a lot. Now we can add a lot of them, maybe like 500. And I want the position to start off a little more random. So we can drag this out, add a random value right here. And just so it's not only going in the positive direction, let's set the minimum to be -1, like that. And if you want this to change in size, you can, just move these around. But usually what I'll do is add a scale node. This is a vector math node set to scale, and then you can, move it. So I'm doing all of this outside of the simulation zone so that, we don't get points every single frame. I'll show more about that later because you can get some interesting effects adding things in every frame. Okay, so press play, this happens. First thing that I thought of doing was just, instead of, adding the offset like this, is you use some noise and it ends up doing interesting stuff because it's noise. So let's add in a noise texture. If you want, you can just plug this in directly and it'll just fly away because everything is going in the positive direction. So to make that not happen, bring in a vector math subtract node, drop this in, set this to 0.5, everything to 0.5. So now this should push in every direction. Long story short, this is 3 different values like we have here, and each one is between 0 and 1. So if you're adding, it's always going to go in the positive direction. But if you subtract it by 5, the 0.5, then the midpoint becomes 0, and it will not just fly away, basically. So let's duplicate this with Shift D, turn this to scale so we can change the strength of it. So now if we press play, this will just spread out and go crazy. You don't want it to do that. Turn the detail down and maybe set the scale to be something quite a bit smaller. Now these will fly away, but in a more clean manner, they'll be going into these trails like that, and they will naturally kind of settle in certain spots that I guess must be low values, closer to 0. So let's make this a little weaker so we can actually see it move like that. If you don't want it to be in trails like this as much, then there are a few things you can do. You can turn the detail up and things will kind of spread apart a little more. Or you can set this to 4D and you can change the W over time and it'll make it so it doesn't settle as often. If you want to do that, you can use a scene time node. You can animate this too, but I like to use the scene time. You can just plug in the seconds. And now, the texture will just change randomly in a smooth way like that. Another thing you can do to make them kind of not go into these trails where they're all following each other is make it so that each point should have a different W value. The way you can do that is with an index node right here. So this is just going to like count the points and give them a number. So, you know, the first point will be 0, the second point will be 1, 2, 3, 4. It just goes on like that. And then when you plug this into here, all of them will have a different W value, and it becomes a lot more random like this. They'll move in the same kind of speed and manner. It's just that they don't really move together anymore. And you can make this more or less apparent with a math node set to multiply. You can divide it too if you want, and just make this like really small. So they will still go in trails, but they kind of diverge from each other a little more. This is a lot more apparent when all of your particles start in the center, because if you're not using this at all, if you're not using the index to change the W, then all of the points will move together like this. But as soon as you plug it in, they will start to diverge from each other a little more like this. And you can see they naturally just kind of branch away and create trails like this. And like I said, the more you turn this up, if you turn it up to like 1, it's almost just like a cloud expanding. It's pretty random. So I'm just going to set this back to 0 for now, but I'll leave it there for, you know, if any of you get the file from Patreon. So let's tidy this up. I'm just going to select all of these, Control J to put a frame around them. Just know that everything in here is just noise being added. Okay, so let's see. Another thing that we can do if you want to like create, if you want multiple particles to be spawned in over time, an interesting way to do that, let's just set this to 1, make it simple. You can add in a join geometry node right here, and then every frame you can make it so that 1 point is added right here, and it's going to create this trail. One thing about doing this is you can see the points are just adding up over time, and they're never really going to get deleted. So if you want them to get deleted, you have to basically create a way to find the particle age, which is not very hard. But before we get down to that, if you have like multiple points right here, you can see they all kind of trail like this. And if you want them to always come in a random position, that's what the seed would be for. You can just use the frame from the scene time, and it'll make it so that every point that comes in will have a random, you know, value, a random position between these values right here. And it looks quite a bit more random, which is kind of neat. Make this smaller. So it's just kind of pouring out now, and it's also still, everything's being affected by this noise still. So yeah, but just so it doesn't add up over time, let's add a particle age. So this is pretty easy. We use a store named attribute node right here. We can just name this age, and let's add a named attribute. And if you click on this and you don't see age, you don't see the thing that you just added, just go back to the first frame with shift and left arrow, and it should appear, hopefully. Let's add this into itself. And in here, we want to add by 1. So I'll search for add, make sure this is set to 1. Okay. So basically what this is doing is it's creating an attribute called age, and every time, every frame that goes by, it's being added by 1. So it's kind of giving us the age of each particle as it comes in frames. And then if we want, we can delete them. So we can bring in a delete geometry node right here. Let's get this named attribute. And we can say for every particle that is older than like 30 frames, delete it. So to do that, we would get greater than. Every particle with an age greater than 30 frames should be deleted. That's what we're doing. Okay, now let's take a look at this. We should see that after a while, they just start deleting. You can see they're deleting about right here. That's the point where they reach 30 frames. If we want, we can turn this up quite a bit higher, maybe 3 times as long, so 90. And this is what's happening. So you can do some interesting stuff with this. First of all, you're not going to have like a ton of points that just keep adding up, which is nice because if you let it go for long enough, Blender is just going to crash. Let's tidy this up too. Call it age. So some other interesting things that you could do with this is make it scale over time or rotate more over time. You could use this named attribute in the shader side of things to change the color over time, things like that. Let's just scale it up or change the scale. We can do that with it's point radius, I believe. Set point radius right here. Let's grab the age, so Shift D, and if it's in a box you don't want it to be there, you can press Alt P. It's the same shortcut as unparenting things. Okay, so if we plug this in, they're gonna get huge because the radius is gonna go up to like 90. So we need to change this. You can like divide it. I like to use a map range node because you can also kind of change whether they're scaling up or down. So let's use a map range. Okay, so we want it, if we want it to scale up, let's see, we can make it so that it starts at a scale right here. We can make it start at something like 0.1 and then scale down to 0, but it's not going to look right until these kind of match. So we need to turn the from minimum to the maximum age. Start over. Oh, you know what? Because we already flipped it around down here, this should be 0 and this one should be 90. Okay, so now as time goes by, they will scale down like this. If you want them to scale up, basically you just want to make sure these are inverted. So you could change this to 0 and this to 0.1. They'll start small and then they'll get scaled up like that. Yeah, you can do interesting things like this. I guess if you wanted it to start small, scale up in the middle, and then end small, you could put something like a color ramp or a float curve in here. So let's do that just to see how it works. I'm kind of just experimenting at this point. Basically, you want it to start at 0 and end at 0, and then in the middle, you can make it scale up like that. And let's change the scale a little bit. Is that right? Doesn't seem to be right. Maybe it's because it's 1. Let's divide this after. Math, divide. So yeah, now it seems like it is working. Let's make this a little more random though. Maybe not. And let's make this go up like this. So it should start small, as we can see. Start small, end small, like that. So it's a little more seamless, I guess, if you do it this way. And we can tidy this up, just make sure everything's together. Okay, what else can we do? I like doing things like adding velocity and creating attractors and things like that. So let's just save this. I'll just call it sim1. And we'll duplicate it, and I'll call this velocity DT. Save that too. Okay, but we're not going to use some of this stuff. Like, I'm just going to delete this, and we'll delete the age and make sure points aren't being added in all the time. Connect this back up. Or actually, let's remove this. And to get started with the velocity, let's just add in a store named attribute. Make sure this is a vector because it's going to be determining like the points in 3D space. So we need three fields, 3 numbers, whatever. I'm going to change this to V for vector, bring in a named attribute. And similar to age, we're going to feed it into itself like this. And we're going to use the velocity to set the position. Let's just plug this into the offset right now. So right now, nothing will happen because we're not really at any point defining how this is changing yet. Basically, instead of setting the position somewhere outside here, we're going to change this value right here. So we can do that with an add node a vector math node set to add right here, and you can just add forces and things like that to it. I'll show you what this does. Basically, let's just set this to 1 point right now and make it a little bigger, and turn the Z up just like a tiny little bit. So basically what this is going to do is it's going to start off slow and then it's going to get faster like that. If we set it to like -0.01 or something like that, it'll be kind of like if you have a ball in your hand and you just let go. So it starts off slow and then it keeps getting faster like that. Okay. And the reason for that is basically it's going to start off like the first frame, it's going to be moving this much. And then the second frame, it's going to add to itself. So instead of, 0.01 is going to be 0.02. And every frame that goes by is going to add this number to itself. And that's why it's getting faster. Similar to the age, like I said. Now, if you want it to eventually stop getting faster, you need to add some sort of dampening. And that is also pretty easy. You just do that with a scale node, a vector math node set to scale. So by default, if you have this set to 1, it's like there's no dampening or no friction or whatever, like no air resistance, and it'll just keep getting faster forever. But if you set this to something like 0.9, it will eventually slow down. So let's make this quite a bit bigger just so we can see it better. So you can see it kind of starts moving at this like consistent pace. But if we have this set to 1, it will just keep going faster and faster. All right, so now we can start adding things to it other than just a force like this. But before we do that, let's just, again, add some downwards force. So -0.01, let's make this smaller. And if you want it to start off with any like initial force, like if you wanted it to be like if you were throwing it, the way you would do that is outside of the simulation zone. You can bring another store named attribute set to V for velocity. You can name this whatever you want, by the way, as long as you're keeping it consistent. And this is going to be the initial force that it starts off with. So without anything, it's just going to fall down. But if we want, we can add a little upwards force like this. See that over time. So it flies up and then it goes down. And this isn't added every frame. It's just the first frame, it moves this much. And so it's like, kind of determining what value this starts at instead of just starting at 0. So let's also push this to the side a little bit. And it's like it's being thrown kind of. It's creating this arc. So this is kind of like, it's kind of like adding gravity. All right, so if you want to use this, you can use it, but I'm going to set it to 0 for now. And we can plug some noise into it like this. Just plug it into the add. And so now basically points that are moving fast will move faster over time and they'll kind of just fly away. So so when you're using velocity, you typically want the forces to be quite a bit smaller, or else they just start kind of going wild. Let's add 50 points, start to fly away like that. Let's see. It's because I still have that upwards force from before. Let's do like 0.01. It's going to give us a similar effect as we had in the other one, except like I said, the particles that are moving faster are going to kind of like move at an exponential speed. Exponential might not be the right word for that. I don't know if it's actually exponential, but it adds to itself over time. Let's create like some orbiting. So to do that, we need this to be attracted to a point in space. So let's start doing that by adding in a new object. We can add in an icosphere right here, like this, and just so that our geometry nodes don't disappear, we can select our particles and then click this little pin icon, and that will make it so that when we select other things, this all stays here. So let's drag in the icosphere now. And we want to make sure this is set to relative so that it pays attention to where it is instead of where, its original position was or whatever. So to get these points to want to be attracted to this or to another point in space or whatever, what we need to do is bring in the position right here and a subtract node, vector math subtract, and you want the position to be in the second one. Basically what this is going to do if we plug this in by itself is actually, first let's scale this down, because if we do this, it's gonna go crazy like this. Let's use a scale node first and set this to something like 0.01. And let's also scale this down a little bit. Okay, so now this is going to be attracted to the 0, point right here. And we're gonna get this weird pulsing motion like that. If we want it to be attracted to like 1 meter higher, then we can set this to 1 like that. And it's gonna start orbiting, that point in space. And it should keep making the same path forever because we don't have any friction or dampening or whatever. But that's what this location thing is for. When we plug this in here, it will be attracted to the origin point, basically. So now we can actually get these points to start orbiting our icosphere. Let's move this to the center, to the side, and restart the simulation. And you can just kind of move this around in real time and just kind of get an interesting path like this. So now this should kind of just orbit it forever. If you want it to actually be attracted to it and settle in on the spot onto the origin point, then you should add some dampening. So we can just turn this down a little to like 0.9 or something, and it will eventually always try to settle on the origin point right there. If you want it to settle onto the actual like points of the mesh, then instead of using the location right here, you can grab a proximity node like this. Make sure to plug the geometry into that. Let's make some space. And you can use the position right here. So it's going to get the position of, the closest face, basically. Let's restart this. And it will try to settle on the face that is closest. And you can make this a little more interesting by adding some noise or, making them a lot bigger to start like that. And this is cool because when you like rotate it or scale it up, like when you scale it up, it'll actually be attracted to the faces instead of just the center of the object. So you can get some like interesting motion. I don't want to settle too much, so let's do like 0.99, and now it'll take a lot longer to rest. And it's nice using the proximity node right here, because then you can get different results depending on how your object is shaped. But yeah, let's add some noise so that these kind of spread out a little over time. Basically, instead of adding another set position, if we want, like I said before, if you want these to have velocity also, you want to add it to the existing velocity. So let's just put another add node and plug the velocity, plug the noise into the add node, sorry. So now these will be constantly moving basically, but they'll always be attracted to the same point. They'll want to settle on the surface. Let's bring this back to the center and go into edit mode and maybe create like Suzanne or something, different shapes. With Suzanne, rotating it should actually make a difference just because it's not, symmetrical in every direction. See, is there anything else I should talk about? I think that might be it. I guess a thing that I would like to try, I think I've done it in the past, is to make these all want to spin just like all the time. So let's try to do that. I think if I take, actually, let's add this to the velocity also. So let's make some room. Add another add node. Let's take the position and I want to rotate it. So let's look for vector rotate. Hopefully this works. We'll leave this set to axis angle, so it'll always rotate on the z-axis right there. Let's just, oh, maybe don't want to do that. Let's scale this down quite a bit first. 0.01, that's a little too much still, 0.001. So they are rotating. You know, I might not have to actually use this add node, and I can probably just plug this in. Interesting. Let's pull everything towards the center, like this. Oh, wait. 0.001. Okay, so everything is being pulled towards the center, and if I plug the position in, is that gonna do anything? Okay, now it's starting to spin, but we're gonna have to balance it so it doesn't spin too much. Otherwise, it'll just fall apart like that. So let's just make sure that the gravity, the gravity force right here is large enough, like 0.01. And we should just get this rotation. If we add some noise to it, how's that look? Let's add some dampening. 0.99, start it over. All right, this is interesting. A little more noise. This is pretty cool. So now if we add this, let's see, is it just gonna naturally start orbiting Suzanne? It seems like it is. So I guess that's how you would always get it to rotate. That's pretty interesting. All right, so let's just go through and label these now, just for, you know, if you end up getting the file from Patreon. So this is going to be the initial velocity, So yeah, if these get really fast, basically, I think the faster they get, the further out they will become. If we turn this up to like 1, they'll just start spinning like crazy and they'll spread out. It's definitely too much. I think like 0.1 is good. Maybe, is that what it was set at? Or is that too much? 0.05. And let's add like way more points. 500. Okay. So if we move this around, we could probably give it a jump start. It's very chaotic. I think the attraction force might be maybe a little too strong. Let's make this, where is it? A little smaller. 0.03, 0.02. There it goes. Okay, let's visualize the velocity, or let's visualize the speed. So to get the speed, I believe that's just a distance. What is it? Distance over time, you know, like miles per hour. You write like m divided by hour. Oh, yeah. So I'll call this speed. Restart that. And so we should get the position. What do we need? We need the velocity and the position. So let's do this is the distance between the original position and the point where they're at now. So I think it's like trying to figure out like how much the points are moving over time, like how much the points are moving every frame. So now we can take this speed, and if we wanted, we could visualize this by just changing the what's it called? The radius or something like that. But instead, let's get some instances. Instance on points right here, and let's use an icosphere because we're not adding rotation, so it'll maybe look weird if they're not rotating. And yeah, let's use the speed also to change the scale. So basically, the faster the speed, the bigger they'll get. We can set this to speed. And oh yeah, this doesn't have to be a vector. This can be a float. Or maybe, is this right? Do we need, I believe this is figuring out the distance, but there is also a distance right here. So if we want, we can use that, keep everything floats. And make sure this is also set to a float. Plug this into scale, move this around. So this is going to get way too big. Let's just divide this by something. Math node, divide it by like 20, maybe 50. So it should start out pretty small. And basically the faster they go, the bigger they'll get, like that. We can just eyeball this if we want to. Let's do 30. All right, and if we want, we can set a material. So let's set material. We don't have any materials, so let's make one. New material. Okay. Let's go back to, or go to shading, and let's actually look at this. Let's turn the background off so we can see a little better under film, like that. Add in an attribute right here, and this is going to be called speed. We can always check that if we want by selecting our plane and checking internal dependencies. It'll tell us the name right there. So the icosphere, this is okay. It has the right material. And now this won't work until we change this to instancer, but we should be able to visualize the speed. Everything's going to look white basically because as soon as it hits 1, it's going to look white, and the speed is going to be moving. It's going to be moving much faster than that. So the thing that I like to do is turn on bloom, and then we can get this to become more bright over time. So even if it goes above 1, you'll get more bloom. So let's turn this maybe like blue or something like that, and plug the factor. You can use any of these pretty much except for alpha, but we know that this value is a float, so we can use the factor, plug that into the emission strength. And so now it should work that like the faster it gets, the brighter it will get also. And we can test that just by spinning it around a little bit. Oh, is this not working? Why is this? Okay, there it goes. So you can see that is very bright now out there, but it starts off not very bright. You can also make this like change color over time, I guess, if you want to. Use something like a color ramp. You might want to divide this first. So let's divide it by 30, just like we were in the other one. And let's make like a rainbow. So let's make this HSV. We can set this to clockwise. Let's make the first color red. So it starts off red, and then it will become blue as it gets faster, like that. We can plug that into the emission color. There you go. So as soon as it hits a speed of 30, it will become blue and it'll stay blue. But it starts off as red, like that. So this is pretty interesting. If you want it to, you know, be able to get faster or whatever, make the gradient a little more obvious, you can just divide this by a higher number and that should work. You might want to divide this if you don't want it to get too bright. Maybe like 20, something like that. I think it's pretty cool. So yeah, that's all for this one. If you want this file, you can get that on Patreon, as always. And yeah, have a good one.